Welcome back to the DevOps track here at PyConAU 2020, which we are extremely online. Hopefully you've been enjoying the track schedule so far today. We've had some great questions, some excellent talks, lots of good interaction, which is fantastic to see. So thank you all for being with us today. Coming up now, we have an amazing talk by our next speaker. Before we get to that, though, I also have some announcements about the program, which have been wrangled over the last couple of hours. So very important and exciting news for Sunday. The details are now up, so do go to the website and check the schedule there. It has our regular sprints, a whole bunch of mentored sprints. We also have some attendee-organised Birds of a Feather meetups, including unofficially, officially, maybe perhaps slightly more official than it was previously, lightning talks, which are a popular feature of PyCon. So our regular lightning czar is coordinating those activities, so do come along. We also have a coding competition, which is going to be announced on Saturday night. So that's tomorrow night. So head over to the schedule, click on the Sunday tab, and you'll be able to find out more. Before you do that, we want you to stay here and enjoy this beautiful talk that we have from Aaron Bassett. Now, introducing Aaron Bassett, he has lived in Ireland, Scotland, Hungary, the Netherlands, and the America. He is a recovering senior software engineer turned award-winning developer advocate. And as a developer, public speaker, writer, and mentor, he spends most of his time making cool stuff and helping other people make unbelievably cool stuff. And he is here to talk to us about whether or not we can keep a secret. So Aaron, welcome. I'm really looking forward to this talk.
Thank you so much for that introduction. Hey everyone, thank you for joining me today. I just want to before we get started, I just like to take a moment really to express my heartfelt thanks, gratitude, and admiration to everyone involved this year's PyCon Australia. They've done such an amazing job in a really very difficult time. It would have been so easy for them to have just skipped putting on a conference all this year and no one would have blamed them. But they didn't. And what they've achieved should really be celebrated. So I want to make a big thank you to them. Okay, with that said, let's get started. So as you heard, I'm Aaron Bassett. You can find me pretty much everywhere as Aaron Bassett because I have zero imagination. Twitter, GitHub, LinkedIn, probably an old MySpace and Bebo account out there somewhere too. You can find me on them all as Aaron Bassett. I'm a senior developer advocate at MongoDB. And for anyone who hasn't heard of MongoDB before, it is a general purpose document-based distributed database, often referred to as a NoSQL database. We have a fully managed cloud database service called Atlas, an on-premise enterprise server, an on-device database called Realm, but we're probably most well known for our free and open source community server. In fact, much of what we do at MongoDB is open source. And as a developer advocate, almost the entirety of what I produce is open source and publicly available. Whether it's a tutorial, demo app, conference talk, Twitch stream, and so on, it's all out there to use. Here's an example of type of code I write regularly. This is a small snippet to perform a geospatial query. First, we import our MongoDB Python driver. Then we instantiate our database client. And finally, we execute our query. Here, we're trying to find all documents whose location is within a defined radius of a chosen point. But even in this short example, we have some secrets that we really shouldn't be sharing. The first line highlighted here is the URI. This isn't so much a secret as a configuration variable, something that's likely to change between your development, staging, and production environments, so you probably don't want this hard-coded either. It's the next line, however, that's the real secrets, our database username and password. These are the type of secrets you never want to hard code in your scripts, not even for a moment. So often I see it where someone has pulled out their secrets into variables, either at the top of their script, or sometimes they'll hard code them into settings.py or similar. I've been guilty of doing this as well. You have every intention of removing the secrets before you publish your code. Then it's a couple of days later, the kids are trying to get your attention, you need to make your morning coffee, or there's one of the other million other things that happen in our day-to-day lives distracting you. And as you get up, you decide to save your working draft, your muscle memory kicks in, and well, that's all it takes. All it takes is that momentary lapse, and now your secrets are public. And as soon as those secrets hit GitHub or another public repository, you have to assume they're immediately breached. Michael Melly, Matthew R. McNeice, and Bradley Reeves from North Carolina State University published a research paper titled "How Bad Can It Get?" Characterizing secret leakage in public GitHub repositories. This research showed that the median time for discovery for a secret published at GitHub was 20 seconds, and it could be as low as half a second. It appeared to them that the only limiting factor in how fast you could discover secrets in GitHub was how fast GitHub was able to index new code as it was pushed up. The longest time in their testing from secrets being pushed until they could be potentially compromised was just 4 minutes. There was no correlation between time of day. It most likely would just depend on how many other people were pushing code at that exact same time. But once the code was indexed, then they were very quickly able to locate the secrets using some well-crafted search queries. But this is probably not news to most developers. Okay, the speed at which secrets can be compromised might be surprising, but most developers will know that the perils of publishing their secrets publicly. Many of us have likely heard or read horror stories of developers accidentally committing their AWS keys and waking up to a huge bill as someone has been spinning up EC2 instances on their account. So why do we, and I'm including myself in that why do we keep doing it? Because it's easy. We know it's not safe. We know it's likely going to bite us in the ass, but it is so very, very easy. And this is the case in most software. This is the security triangle. It represents the balance between security, functionality, and usability. It's a trade-off. As 2 points increase, one will always decrease. If we have an app which is very secure and has a lot of functionality, it's probably going to feel pretty restrictive to use. If our app is very secure and very usable, it probably doesn't do very much. A good example of where a company has traded some security for additional functionality and usability is Amazon's one-click buy button. It functions very much as the name implies. When you want to order a product, you can click a single button, and Amazon will place your order using your default credit card and shipping address from their records. What you might not be aware of is that Amazon cannot send the CVV with that order. The CVV is normally 3 numbers in the back of your card above the signature strip. Card issuers say that you should send the CVV for each card not present transaction. Now, a card not present means that the retailer could not see that you have the physical card in your possession. So every online transaction is a card not present transaction. Okay, so the issuers say that you should send your CVV each time, but they also say that you must not store it. This is why for almost all retailers, even if they have your credit card stored, you will still need to enter the CVV during checkout, but not Amazon. Amazon simply does not send the CVV. They know that that decreases their security, but for them, the trade-off for additional functionality and ease of use is worth it. Now, a real bad example of where a company traded security for usability happened at a thankfully now defunct agency I worked at many, many years ago. They decided that while storing customers' passwords in plain text lowered their security, being able to tell the customer their password over the telephone when they called was worth it in usability. It really was the wild, wild west of the web in those days. So a key tenet of everything I'm suggesting here is that it has to be as low friction as possible. If it's too hard, or if it reduces the usability side of our triangle, then people simply will not adopt it. It also has to be easy to implement. I want these to be techniques which you can start using personally today and have them rolled out across your team by this time next week. It can't have any high costs or difficult infrastructure to set up and manage, because again, we're competing with hard-coded variables, without a doubt, the easiest method of storing secrets. So how do we know when we're done? How do we measure success for this project? Well, for that, I'm going to borrow from the 12-factor apps methodology. The 12-factor apps methodology is designed to enable web applications to be built with portability and resilience when deployed to the web. And funnily enough, it covers 12 different factors: codebase, dependencies, config, backing services, build, release, run, and so on. We're only interested in number 3, config. Here's what 12-factor apps has to say about config. A litmus test for whether an app has all config correctly factored out of code is whether the code base can be made open source at any moment without compromising any credentials. And this is super important, even for those of you who may never publish your code publicly. What would happen if your source code were to leak right now, right this minute? In 2015, researchers at Internet Watch found that 9,700 websites in Alexa's top 1 million had their .git folder publicly available in their site root. This included government websites, NGOs, banks, crypto exchanges, large online communities, a few porn sites, and MTV. Deploying websites via Git pulls isn't as uncommon as you might think. And for those websites, they're just one server misconfiguration away from leaking their source code. So even if your application is closed source, with source that will never be intentionally published publicly, it is still imperative that you do not hard code secrets. Leaking your source code would be horrible. Leaking all the keys to your kingdom would be devastating. So if we can't store secrets in our code, where do we put them? Environment variables are probably the most common place. Now remember, we're going for ease of use and low barrier to entry. There are better ways for managing secrets in production, and I would highly encourage you to look at products like HashiCorp's Vault. It will give you things like identity-based access, audit logs, automatic key rotation, encryption, and so much more. But for most people, this is going to be overkill for development. So we're going to stick to environment variables. But what is an environment variable? It is a variable whose value is set outside of your script, typically through functionality built into your operating system, and are part of the environment in which a process runs. And we have a few different ways these can be accessed in Python. Okay, so here we have the same code as earlier, but now we've removed our hard-coded values, and instead we're using environment variables in their place. Environment is a mapping object representing the environment variables. It is worth noting that this mapping is captured the first time the OS module is imported, and changes made to the environment after this time will not be reflected in environment. Environment behaves just like a Python dict. We can reference a value by providing the corresponding key, or we can use get. The main difference in the two approaches is when using get, if an environment variable does not exist, it will return none. Whereas if you're attempting to access it via its key, then it will raise a key error exception. Also, get allows you to provide a second argument to be used as a default value if the key does not exist. However, there is a third way you can access environment variables. Get_env. Now, get_env behaves just like environment.get. In fact, it behaves so much like it, I dug through the source to try and figure out what the difference was between the two and the benefits of each. But what I find is that there's no difference. None at all. Get_env is simply a wrapper around environment.get. I'm sure there's a very good reason for this beyond saving a few keystrokes, but I did not uncover during my research. If you know the reasoning behind why get_env exists, I would love to hear it. Now, we know how to access environment variables. How do we create them? They have to be available in the environment whenever we run our script. So most of the time, this will mean within our terminal. We could manually create them each time we open a new terminal window, but that seems like way too much work. I'm very error prone. So where else can we put them? If you're using virtual env, you can manage your environment variables within your activate script. It's a little back to front in that you'll find a deactivate function at the top, but this is where you can unset any environment variables and do your housekeeping. Then at the bottom of the script is where you can set your variables. This way, when you activate your virtual environment, your variables will be automatically set and available to your scripts. And when you deactivate your virtual environment, it'll tidy up after you and unset those same variables. Personally, I'm not a fan of this approach. I never manually alter files within my virtual environment. I do not keep them under source control. I treat them as wholly disposable. At any point, I should be able to delete my entire virtual environment and create a new one without fear of losing anything. So modifying the activate script is not a viable option for me. Instead, I use dir_env. Dir_env is an extension for your shell. It augments existing shells with a new feature that can load and unload environment variables depending on the current directory. What that means is when I cd into a directory containing an env_rc file, dir_env will automatically set the environment variables contained within for me. Let's look at a typical dir_env workflow. So first, we create an env_rc file and we add some export statements. And we immediately get an error. For security reasons, dir_env will not load an env_rc file until you've allowed it. Otherwise, you might end up executing malicious code simply by cding into a directory. So let's tell dir_env to allow this directory. Now I've whitelisted the env_rc file, dir_env has automatically loaded it for us and set a db password environment variable. Then, if we leave the directory, dir_env will unload and clean up after us by unsetting any environment variables it set. Now, you should never commit your env_rc file. I advise adding it to your project's getignore file and your global getignore file. There should never be a reason why you would ever want to commit an env_rc file. You will, however, want to share a list of what environment variables are required with the rest of your team. The convention for this is normally to create an envarc.example file, which only includes the variable names but no values. You can even automate this with grep or similar. Okay, so we covered keeping secrets out of our source code, but what about if you need to share secret files with coworkers? Let's take an example of when you might need to share a file on your repo, but ensure that even if your repository becomes public, only those authorized to access the file can do so. Okay, so MongoDB supports encryption at rest and client-side field level encryption. With encryption at rest, the encryption occurs transparently in the storage layer, i.e. all data files are fully encrypted from a file system perspective, and data only exists in an unencrypted state in memory and during transmission. Client-side field encryption, applications can encrypt fields in documents prior to transmitting data over the wire to the server. Then only the applications with access to the correct encryption key can decrypt and read the protected data. Deleting an encryption key then renders all data encrypted using that as permanently unreadable. So if encryption at rest, each database has its own encryption key, and then there's a master key for the server. But with client-side field level encryption, you can encrypt individual fields and documents with customer level keys. I should point out that in production, you really should use a key management service for either of these. Like really use a KMS, don't use a local key. But for development, you can use a local key. So to generate our key, we've got these commands. The first one generates a key file to be used for encryption at rest. It sets our permissions and then enables encryption on my server. Now, if multiple developers need to access this encrypted server, I would need to share this key file with them. And no, I'm not just going to Slack it to them. We're going to store the key file in our repo, but we're going to encrypt it first. GitSecret encrypts files and stores them inside the Git repository, which sounds perfect, exactly what we need, with one little caveat. Remember, these processes all need to be safe and easy. Well, GitSecret is easy-ish. GitSecret itself is very straightforward to use, but it does rely upon PGP. PGP, or Pretty Good Privacy, is an encryption program that provides cryptographic privacy and authentication via public and private key pairs. And it is notoriously fiddly to set up. There's also the problem of validating a public key belongs to who you think it does. Then there are key signing parties, web of trust, and lots of things that are way out of scope for this talk. Thankfully, there are pretty comprehensive guides for setting up PGP on pretty much any OS you can imagine. So for the sake of the talk, I'm going to assume you already have PGP installed and you have access to your colleagues' public keys. So let's dive into GitSecret. First, we initiate it, much the same as we would a Git repository. This will create a hidden folder .getsecret. Now we need to add some users who should know our secrets. This is done with GitSecret tell, followed by the email address associated with their public key. When we add a file to GitSecret, it creates a new file. It does not change the file in place. So our unencrypted file is still within our directory. We must ensure that it is not accidentally committed. GitSecret tries to help us with this. If you add a file to GitSecret, it'll automatically add it to your gitignore if it's not already there. If we take a look at our gitignore file after adding our key file to our list of secrets, we can see that it has been added along with some files which GitSecret needs to function, but should also not be shared. Now, at this point, if we look at the contents of our directory, we can see our unencrypted file is there, but still no encrypted version. First, we have to tell GitSecret to hide all the files we've added. Now, if we ls again, we can see the encrypted version of the file has been created, and we can now safely add the encrypted version to our repository and push it up. Then, when one of our colleagues pulls down our encrypted file, they can run reveal, and it will use their private key to decrypt it. GitSecret also comes with a few commands to make managing secrets and access easier. The who knows command will list all users who are able to decrypt secrets in a repository. Handy if someone leaves your team and you need to figure out which secrets need to be rotated. List will tell you which files in a repository are regarded as secret. And if someone does leave and need to remove their access, there is the rather morbidly named kill person. The kill person command will ensure that person cannot decrypt any new secrets which are created, but it does not re-encrypt any existing secrets. So even though the person has been removed, they will still be able to decrypt any existing secrets. There's little point in re-encrypting the existing files as they will need to be rotated anyways. Instead, once the secret has been rotated, then you run hide on the new secret, and the removed user will not be able to access this new version. Another tool I want to look at is confusingly called GITZEAKS, because developers behind Git tools have apparently even less imagination than I do. GITZEAKS scans commits, commit messages, and no fast-forward merges to prevent adding secrets into your Git repositories. All the tools and processes we've looked at so far have attempted to make it easier to safely manage secrets. This tool, however, attacks a problem in a different way. Now, we're going to make it more difficult to hard code secrets in your scripts. GITZEAKS uses regexes to attempt to detect secrets within your commits. It does this by using Git hooks. GITZEAKS install will generate some Git templates with hooks already configured to check each commit. We can then specify these templates as the new defaults for any Git repositories. And because GITZEAKS is from AWS Labs, it comes with providers to detect AWS access keys built in. But you can also add your own. A provider is simply a list of regexes, one per line. The recommended method is to store them all in a file and then cat them. But this is some drawbacks. So some regexes are pretty easy to recognize. This is the regex for an RSA key, straightforward. But what about this one? I'd love to know if anybody recognizes this right away. It's actually the regex for detecting Google OAuth access tokens. And this one? Facebook access tokens. So as you can see, having a single large file with undocumented regexes could quickly become very difficult to maintain. Instead, I placed mine in a directory neatly organized. Separate files depending on the type of secret I want to detect. And then in each file, I have comments in white space that help me group regexes together and document what secret they're going to detect. But GITZEAKS will not accept these as a provider, so you need to get a little creative egrep. We collect all the files in our directory, strip out any lines which are of a hash or which are empty, and then return the resultless transformation to GITZEAKS, which is exactly the same input as we had before, but now it comes from a much more maintainable system than one long undocumented list. If GITZEAKS and our customer providers installed, we try to commit a private key, it will throw an error. Now, GITZEAKS can produce false positives. The error message will give you some examples of how you can force your commit through. So if you are totally committed to shooting yourself in the foot, you still can. But hopefully, it introduces just enough friction to make hard coding secrets more of a hassle than just using environment variables. Finally, we're going to look at a tool for when all else fails. GitLeaks. Audit Git repos for secrets. GitLeaks provides a way for you to find unencrypted secrets or other unwanted data types in Git source code repositories. GitLeaks is for when, even with all your best intentions, a secret has made it into your repo, because the only thing worse than leaking a secret is not knowing you've leaked a secret. It works in much the same way as GITZEAKS, but rather than inspecting individual commits, you can inspect a multitude of things. A single repo, all repos with a single user, all repos under an organization, all code in the GitHub PR, and also inspect GitLab user groups too. I recommend using it in a couple of different ways. One, have it configured to run as part of your PR process. Any leaks, block the merge. Two, run it against your entire organization every hour, day, week, or whatever frequency you feel is sufficient. Whenever it detects a leak, you'll get a nice report showing which rule was triggered, by which commit, in which file, and who authored it. So, in closing, keep secrets and code separate. If you must share secrets, encrypt them first. Yes, PGP can be fiddly, but it's worth it in the long run. Automate, automate, automate. If your secret management requires lots of manual work for developers, they will skip it. I know I would. It's so easy to justify to yourself. It's just this once, it's just a little proof of concept. You'll totally remember to remove those secrets before you push. I've made all the same excuses to myself too. So keep it easy. Automate where possible. And late is better than never. Finding out you've accidentally leaked a secret is a stomach-dropping, heart-racing, breath-catching experience. But leaking a secret and not knowing until after it's been compromised is even worse. So run your GitLeak scans, run them as often as you can, and have a plan in place when you do inevitably leak a secret so you can deal with it quickly. So that's everything about secrets. Thank you very much for your attention. Please do add me on Twitter at @Bassett. I would love to hear any feedback or questions you might have. If you would like to revisit any of my slides later, they will all be published at notice shortly after this talk. I'm not sure how much time we have left for questions, but I will be available in the hallway chat if anyone would like to speak to me there. I know I've been sorely missing seeing everyone at conferences this year, so it would be really nice to catch up and chat. And thanks again to everyone who attended my talk and to PyCon Australia organizers for a wonderful conference. Thank you.
Fantastic. That was a great talk.
And I'll pop my
bit of a whirlwind
tour
of stuff as well.
Yeah.
We have a whole bunch of questions, and unfortunately we don't have time to cater for them all. I think we've got time for about one.
Sure.
Picking which one is really difficult. So questions about the transition from how you would do this, from what you were saying about, like, well, I'm just doing this in development and I want to use something more in production. How would you recommend that people make that transition from kind of just mucking around on my machine to now I need to make this a bit more production ready? How would they transition?
The good thing is if you're managing all of your secrets within, say, environment variables, so they're not included anywhere in your source code, then really all you're looking at is whatever your orchestration platform is, whatever is putting together your production environments, is it just needs to set those same environment variables as well. Okay, so not going to be like an mvarc file like I had in my example. They may be coming from HashiCorp Vault, or they may be coming from some other kind of secret store. But as long as they can get them into the environment, then your scripts just run the exact same way. Right.
Cool. Okay, that doesn't sound too difficult. I'm sure there are lots of questions around some of the nuances, and I really encourage everyone to jump into the hallway chat, because we've got a relatively short time spin around for the next talk here, and I know that people want to ask you some questions. So do ask those questions.
In the chat, and if I don't get to remind everybody in the chat, as I said, my Twitter there is on there. Please, I'm pretty active there. My DMs are always open as well. So if you don't want to ask me something in public, I'm happy to receive any private questions too. So hopefully I'll get everybody in chat, but if not, please feel free to reach out.
Awesome. Thanks so much, Aaron.
Okay. Thanks again, everybody.
That's great. So coming up in about, I think we've got about 9 minutes of turnover. I think about 8 minutes remaining. We have Thomas Woolford coming up next with a chat. His talk is called "A Sack Full of Angry Snakes: Taming Your Python Dependencies with Nix," which sounds fascinating. So do be back here in about, like I said, about 8 minutes. But if you have some questions, we have Aaron, who's going to be in the hallway tracks in the hallway chat rather, to talk to everyone. So we'll see you again on the stream in just a few minutes.